we're going to look at how you calculate the slope and the intercept for the least squares regression line. And we're going to do that both by hand and in Excel. Most of the time we'll be doing this in Excel, but I do want to show you where that formula comes from. So you do need 5 things to find this. You need the mean and standard deviation of the explanatory variable, the mean and standard deviation of the response variable, and the correlation coefficient. So once you have those 5 things, the first thing you want to calculate is the slope. So the slope, you're going to take the 2 standard deviations and divide them. So the standard deviation of y over the standard deviation of x, and then multiply that by the correlation coefficient. So the cool thing about this is we know that standard deviations are always positive. And so the 2 standard deviations, if they're both positive and we divide them, we still get a positive number. And so the sign of the slope, whether it's uphill or downhill, is determined only by the correlation coefficient. So the correlation coefficient is positive, we're going to get a positive uphill slope. And if it's negative, we'll get a downhill negative slope. So that's why those we had that property back in chapter 4. And then once you've calculated the slope m, then the intercept, you're going to take the mean of y minus the slope times the mean of x. Okay, so we're going to do that with a set of data on coral reefs. So how sensitive to changes in water temperature are coral reefs? To find out, scientists examine data on sea surface temperatures and the amount of coral growth per year at locations in the Red Sea. So to do this, we're going to need to go over to Excel. So go ahead and hop over to Canvas and download the data set for chapter 5, and I'll see you in Excel in just a moment. All right, so here's the data set in Excel. It's the tab called just coral. There's another one called coral residuals, and we'll look at that later. You want the one that just says coral. And you'll see I've actually listed the x values going horizontally, and same with the y values. So this should match what you have in your notes. And I'd love for you to just get some more practice finding the mean and standard deviations. So go ahead and pause the video and see if you can find those 5, as well as then use a calculator to get the slope and intercept. So go ahead and give that a pause. All right, so hopefully you gave that a try. Let's go ahead and find these together. So standard deviation is equals STDEV. And I'll open some parentheses and then highlight this X data. And let's see, I'll get the standard deviation for the Y as well while I'm here. And then remember that the mean has a different name in Excel. So this is really the average. So I'll do equals the average. Get both of these. So I have 2 standard deviations and 2 means, and then I need my correlation coefficient, so equals CORREL, open parentheses, and then this one requires 2 separate highlights. So I'll highlight the x variable, I'll put a comma, and then I'll highlight the y variable. Okay, and so I get a negative correlation coefficient, so that means that I'm going to have a negative slope when I do this. So my point should be going downhill when I make this graph. To get the slope, you can definitely do this with a calculator. You can also do it in Excel. So you can use Excel as a calculator by putting an equal sign in, and then I'm going to click on the box that has the R, and then that'll be times, and then I need the standard deviation of Y, so that's the one that's 0.15, divided by the standard deviation of X, so that's the 0.42. So I have R times SY divided by SX. So I get negative 0.303. And then the intercept is going to be an equal sign. And then I need the average from Y. So that's 2.515. So I'll click on that box and I'll put a minus sign. And I'm going to click on the box that has the slope and put a times. The times is just a little star. And then the mean of x is this 30.28. So I get an intercept of 11.692. So if I put this together, my equation is going to look like y equals negative 0.303x plus 11.692. So that's what I'm getting when I calculate it by hand. Now to do this using Excel, we're going to go ahead and make our scatter plot here. So I'm going to highlight my data. I'll go to Insert. Here is my data. So I have temperature along the bottom. I have my coral growth here. And this definitely does look downhill. So that's a great start. That's what we were expecting to see from our slope. And let me go ahead and label these axes. So I'll add a horizontal and a vertical on here, just so I can see what I'm looking at. So this will be the sea temperature. And the other one will be coral growth. Right. And then to fit a regression line on here, so we did look at this briefly in chapter 4, and we went to add a chart element, and we went down to trend line, and I told you to click on linear. So if you want to do more with the trend line, you actually, instead of doing linear, you want to bypass that and go down to where it says more trend line options. When you click on that, it should open a panel on the right side. You'll see that list of choices, exponential, linear, etc. So linear has been marked. And then all the way down at the bottom of the panel, you want to click the last two boxes on here. So the one that says display equation on chart, and then display the R squared value. Okay, and I'll talk about what the R squared is in just a little bit. So if you click on both of those, it'll give you both of those things in a box. And then let me make this a little bit bigger so it's easier to see. All right, so they have the equation is negative 0.3031, which matches ours, where they just have one more decimal place, plus 11.692. So that's exactly what we got when we calculated this. So these two are the same. And then the next part of the note says the coefficient of determination is R squared. So that's the 0.7458. So go ahead and write that down. And then the last question we'll answer together in the next video. There is another way to get this R squared value. This R squared is the same that's coming from this R here. So if I take this number here and square it, then I'm going to get the 0.7458. So exact same process, just another way of getting to that. All right, so come back to the next video and we'll actually take a look at what that means.